right, Chloe, you just let me know if you don't agree with any of my answers. All right, today's Monday. It is the test review for Unit 3. We are being recorded. All right, first one. At midline. And again, all of you, I sent this out, the blank review on Friday, so hopefully some of you other than Chloe work these out. All right, so what is the midline of the equation of f of x equals negative 2.4 cosine of the quantity 0.8x minus 3.2 minus 2.4? The midline. Y equals negative 2.4. Yep. So midline is the same thing as the vertical shift. Yes. Y equals negative 2.4. Next one. We got true or falses. So what are the key features of the graphs of the parent trig functions? First statement says the asymptotes of f of x equals secant of x are pi units apart. Is that true or false? False. That false is wrong. It is true. Yep. And you can, if you don't know on the top of your head, you can always just graph. You can go back to the lessons and look in there because they're probably stated somewhere in there. Or you could just graph secant of x, for example, and see if your asymptotes occur every pi. And for secant, they do. Right. The period of cosecant of x is pi. Is that true or false? Is false. All right. Third one. The y-intercept of tan of x is 0, 0. True or false? That is true. Yep. In the last one, the max value of sine of x is 1. That is true. Yep. It is doubtful you're going to get any of these four, but you'll get other statements that ask questions along this line about other trig functions, and you'll have to look in your notes or graph it out to see if it's true or false, or if you know top of your head. But always verify if you can. All right. What is the exact value of inverse cosine or arc sine of negative 1/2? You could use your unit circle or you could type it in. What is the exact value? What do we get? 2 pi over 3. 5 over 3 is right. Nice job. So your test will want it in radians. Or not radians. Yeah, this would be radians, sorry. Yeah, 2 pi over 3 is radians. All right, what is the amplitude of the graph of the trig function? F of x equals negative 4 sine of the quantity 2x minus pi over 6 plus 5. What is the amplitude? Just 4. It is just 4. You were right. So don't be fooled by this question if you happen to have a negative in front. Remember, amplitude is always positive. That negative inside just causes a reflection. It flips it, right? Yeah, it flips it over the x-axis. So remember, amplitude is always positive. Don't miss this easy question. I know in my lesson last week, I had a mistake and I had a negative in front, even though I did state it during that lesson because someone asked me about it. Amplitude is always positive. All right. What is the period of y equals cosecant of x. Cosecant of x. I'm seeing 2 pi. Let's see if 2 pi is right. 2 pi is correct. So far, these questions are pretty easy. Would you agree? Seem almost a little too easy. Yeah, I thought the test was. So far, the test is pretty easy. Don't jinx it. I hope I do. Okay, what is the exact value of the expression cosine of the arc sine of negative radical 2 over 2 plus the arc sine of cosine of pi over 6? So when doing these, you do two things. You can just type it all in. You may want to just type maybe this segment in separately to get two fractions. Or you could, when doing these, you work from the inside out. So you look at, all right, what's the arc sine of negative radical 2 over 2? So you say, okay, well, sine is y. So when the y value is negative radical 2 over 2, what do I get? And then that answer that you get, you say, okay, now what's the cosine of that? Going back and forth, but obviously the easiest way is just type it in. You should get radical 2 over 2 for this first piece here, and you should get pi over 3 for this second piece. That works too. Yep. So doing it both ways, using the inner circle first, and then after you get to your answer, then check with the calculator to see if it agrees with what you're thinking. I think it's an excellent way to do it. All right. We have to combine this. To add fractions, you need to have the same denominator. So I multiply top and bottom by 3 on the first one, top and bottom by 2 on the second one, and that makes me have a denominator of 6. And then 3 radical 2 plus 2 pi in the numerator, all over 6. So your answer on your test wants it as a single fraction. So some calculators that if you type all this in at once, it will not give you a single fraction. It will probably give you a decimal. That's probably why you want to do maybe a piece at a time, like I did here. Because I would say more calculators can do that. And then from here, you can try typing this in to see if you get down this answer. But if you don't, you're going to have to do it by hand. Yep. So you got to do it by hand. And if you forget how to add fractions together, you might want to do a quick YouTube search on adding and subtracting fractions to watch a little refresher. All right, and just so you know, radicals are kind of like, they act like variables in the sense of looking for like terms. So I could say this is like 3x plus 2y, and they're not like terms, so I can't combine them. You can think of it like that too. All right, any questions on this one? All right. All right, Chloe, are you still agreeing with my answers? Good. Don't please let me know because I probably had a typo somewhere. All right, so we got to graph the function y equals sine of x minus 2. So if you notice, I don't have the x minus 2 in parentheses, so make sure if you type this in, it's the same way. This minus 2 isn't inside the parentheses, so it's not the sign of that quantity, it's just the sign of x, if that makes any sense. So what does this minus 2 act like? What is this piece telling us? It's the midline. Yep. Is the vertical shift. Yep. Midline, vertical shift, same thing. So if you graph this, it would look like this. So here's the parent function here. And then on your test, it'll give you some directions like graph the midline first and then graph a max or a min. So you would plot this point first, then you would plot this point, and then it would automatically create the graph for you. So if all of you did the learn and practice modules and the quizzes, you should have had practice of using their graph tool to graph these. So if your test is the first time doing this, your fault. It's not true, Araceli. Antonio, to answer your question, it can. So you can write it like that, and you'll see it both ways. So they mean the same thing. So let me just write it in chat. So if I have sine of x minus 2 is the same as sine of x minus 2. And then sine of x minus 2 is not the same as the first two.
So if there's no parentheses around the x, we can assume that the -2 is just the vertical shift.
Correct.
And not horizontal. Okay.
Yes, that is a perfect assumption to make. And you'll see it like that. The only way they'd want you to include that -2 in the parentheses if they actually had the parentheses. So sine of x minus 2 is difference. And sine of x minus 2. Unfortunately, people who aren't here in the live session cannot see what I'm typing. Yeah, it brings me to a good point. You might want to start coming to live sessions. I think it's very helpful. People who come to live sessions have higher grades than the people that don't. And there are a few exceptions. There are a few exceptions. But majority of the class, people who come to live sessions are doing better, much better. But watching the recorded sessions, that's also great too. And that's why I think people still have high grades. Is they come to the recorded sessions and they watch that. They just can't ask questions. And they're probably a few days behind, if not more. I can see who watches the recordings, yes. Unless you watch the recordings on YouTube, then obviously I don't know. I put them on YouTube because I think it's a lot easier to go to the YouTube channel and then pull up the playlist for Unit 3 and then just watch them. They're all right there for you. And then you can also set the playback speed to make it like a 1.5, for example, and you can skip around a lot easier. So, all right, let's go on. Okay, period, amplitude, and midline. All right, so this word problem says Daisy walks in the neighborhood park every morning following a looping path through the park. She walks over this route 3 times each morning. The distance measured in feet. Daisy is from her home at any minute m, and to her route is modeled by the sinusoidal function f of m. All right, this table shows that So these word problems, I think, how could it be a sinusoidal function? And they make it fit somehow, even though it's probably not realistic. It's still a word problem. Regardless of the situation, you're given this table of data. Now, one thing I could suggest maybe doing is going into Desmos or GeoGebra, and they have a table function that allows you to enter all of this data in a table, and it'll plot the points automatically for you on the graph so you can see it visually. Honestly, I think that's probably a really good way to start this problem than just trying to look at the data and visualize it. Plus, I don't think these are the best problems, but let's look at this one. All right, so looking at this data, this is from m is 0 to m equals 12, and you have all of these points. Now, you can't assume from 0 to 12 is one period. You can't assume that. That's why you need to look at the data. So remember, a period is the time it takes before your graph starts to repeat. So it has to go up and then down and then back to the starting point, and then it repeats. That would be one period. So graphing this in GeoGebra or Desmos, all these points, and seeing it might really help. But looking at these points, what is the period of this? So we got p equals 6. We got p equals 12. I think they're both really good guesses. So let's kind of look at this because 450 from 0 to 6. All right, so let's look at this. So it goes 450, then it goes up higher and higher and higher, and then it goes down again, and then down, and then back to 450. So this is the reason why you want to graph it. So if you can visualize it, the graph is going up and then down. So we have a maximum. But in this sinusoidal function, we haven't created the minimum yet. So from 0 to 6 is only possibly half of your sinusoidal function. Remember, we need the up, the down, and then back up again, so you have your local max and your local min, if that makes sense. So you're only creating one hump and not the bottom hump. That makes sense of why it's not 6? So again, graph these to see them. Seeing is believing, right? All right, so from 0 to 6, so then 450, and then it keeps going down, 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 and then it goes back up again, back up, and then back up to 450. And then looks like at 450, so it goes up, it goes down, it goes back up to 450, and that's where it restarts. So what is the period of this? You would think it's 12. You would think it's 12. It's not. So this one, I know these drive me nuts. The period of this is actually 11. Because at 12, it starts to repeat. So this is why you want to graph them. So it's actually from 0 to 11, and then we start repeating at 12. So that's why it's not 12. I agree. I do not like these problems. Yes, the one-year quiz is weird like this. Yep. This is how your test is doing this. So I kind of took this almost from your test, but with different points. So yeah, it's from. So I would graph these. I would plot these points so you can see it.
If we plot it, though, does it look like it's 12 or does it look like it's 11?
Should look like it's 11
Okay.
for this one. What's the amplitude? $250. It is $250. Yep. Yeah, I think the period is still 12 for this one. If you graph it, graph this one and then get back to me today, somebody. Or at the very end, we'll at the very end we'll do this one together off the recording because I still think it's 12 personally, but the answer key that I have for this problem is actually says 11. All right, what's the midline? $450. Yep. Y equals 450. Let me double check the test for you. Because that problem might actually be just select the right answer. Type it in yourself. Let's find out. I think if it's select the right answer, I don't think it's going to have 11 or 12. It's going to have one or the other. It's not going to have both to confuse you completely. Hang on a moment, still flicking through. Still loading. Wow. Okay, finally loaded. Give me a second to find this question. All right, you are in luck. You're going to have a bank of answers. You have to just drag and drop the answer to the right box. So, like, say for example, this question, you wouldn't have 11 and 12 as a choice. You would have just 11 as a choice. So you choose 11, even though I actually agree. I think it is 12. So it makes that problem easy in that sense. So, yeah, hopefully you feel better about it. I know I do.
Quick question.
Yep.
Can we go over the other way to the midline? Because people are a little bit confused on that. I see here you did the minimum plus the amplitude. You also did the other way, subtracting it.
So I did the, what did I do?
Minimum minus amp plus the amp.
Yeah, so I did the amplitude because I found it in the previous step, and then I took the minimum which was 200. Yeah, 200 is right here. So I had 200 plus the amplitude to get 450. You also could have done the maximum, which is
700 minus 250. 450.
yeah, 700 minus 250 to get 450. You also could have graphed it, and you could have seen visually that the midline is 450 right on the graph. So there's a couple ways to do it. Does that help? Good, good. All right. There's also a correction. So I'm going through these test questions, and there's an error on your test that will make this problem impossible to solve. So I would snip this page, because if you are the unlucky one to get this variation of that word problem, it's going to give you this table of data. Well, this table doesn't have enough data to answer the question. So I went through these 3 word problems, and I worked all 3 of them out, and this variation I was unable to solve. I was only able to construct this table that I'm giving you. This is the corrected table, because I had the answer. So I used the answers to figure out the missing data points. So anyway, if you get this table data, you need to use this one instead, or you won't be able to answer the question. Yeah, so in order to get access to the test, you need a password, and the password is at the end of this lesson. So by you coming here, I really hope you watch the entire thing, or you won't know this and you're going to miss it. And that's your fault. Yeah, don't skip around. The worst thing, what you can do is just set it at 1.5 speed and just watch it really quick. And plus, why wouldn't you want to watch this review? It's pretty close to what to expect on the test. But anyway, I can't control what you guys do at home, unfortunately. I wish I could. No, really, you think about it. Online teachers versus teachers in person. I really feel like I have less control of what you do in math, because you're not there in front of me. All right, everyone snip this page. Okay, next question. Even and odd symmetry. Is the trig function even or odd? So is sine, and then I give you the definitions from this. And I even give you the lesson 3.02 day 1. You might actually need to go back there to see the other trig functions that I purposely left out, because they're probably going to be in your test. All right, is sine even or odd? It is odd. I guess you had a 50-50, right? All right, what is cosine? Cosine is even. What is tangent? Tangent is odd. Yep. So on your test, you will probably not have these 3 trig functions. You'll probably have the other 3, which you'll have to look back in this lesson to get those. I didn't want to just give you the answer to the test, so I just presented these 3 instead. All right, inverse trig domain restrictions. All right, the interval of the inverse will be the same as the domain restriction for the parent trig function. All right, the restricted domains for the functions are as follows. So what is the domain? And I actually gave you the picture to kind of give you the answer for these three. Actually, I didn't tell you which one was sine, cosine, or tangent. All right. What is the domain for sine? Nobody knows. The domain restriction. Negative pi over 2 to pi over 2. Yep, in brackets, of course. So that must mean this first graph is sine. So you might want to label on your paper, this is your sine graph, of course, which means the cosine must be from 0 to pi. And then for tangent, it is from negative pi over 2 to pi over 2. Parentheses because there's asymptotes. Now remember, these domain restrictions are not the same as a period. So you can refer back to this lesson of why this is. Little hint, it has to pass the vertical and horizontal line test when you go from the original to the inverse. So that is why. All right, midline and period. What is the midline and period of the function shown in the graph? So you'll be presented this graph, and it's going to ask you, well, these questions. All right, let's do the easy one. What's the midline? We'll do the midline first. What's the midline of this graph here? Y equals negative 4. You can see that. Yep, that is the midline. Y equals negative 4. And I did the math way too. I did the min plus a max, and then I divided by 2. So that's that formula we learned last week to get the same answer. All right, what is the period? 2 pi over 3. Let's see if that's true. So we start here, it goes down, and then back up, and then it starts to repeat starting here, and that is, in fact, 2 pi over 3. So it does repeat starting at this point. So, yep, I would agree. 2 pi over 3. All right, next one. This is the equation of a cosine function whose graph is a reflection over the x-axis, has an amplitude of 10, a period of pi over 4, and a vertical translation of 3 units up. Okay. So we're given all of this info. You're going to have to figure out, put it all together to create your cosine function. You need your amplitude, you need your k value, you need your c value, you need your h. All right, let's figure. Well, it says amplitude is 10, right? So A equals 10, but it also says the graph is a reflection over the x-axis. So what should be first in my equation? Negative sign and a 10. Yep. All right. Next, we need to figure out the k value. So how do we find the k value for this cosine function? 2 pi is the period. Yep, so we use that formula, P equals 2 pi over K. You are correct. And somebody already said the period is pi over 4. So I just plug that in, and then we solve for K. So I'm going to just flip-flop K and pi over 4, a little math trick. And then I'm going to flip and multiply 2 pi times 4 over pi. And then I get 8. Okay, C. Does this problem tell us there's a phase shift or a horizontal shift? Does not. All right, so that saves us a bit of work. And then what is the vertical shift? 3. Yep. There's final answer. Not too bad. So something to note, this one says a cosine function. So cosine and sine have a period of 2 pi, but what if this was a tan function? What would the period be? The period would be pi. Just don't forget that. I'm not saying you're going to have a tan function, but you could, right? And cotangent, yep. Cotangent, tangent have a period of pi. All right, we're almost done. All right, graph the function y equals 5 cosine of the quantity pi over 4x plus pi over 2. Oops, I meant to cover the graph up. This is the answer. Whoops. Okay. So you could just type it in Desmos or GeoGebra and just see what it looks like, and that's probably the easiest way to do it, right? Or we can actually figure out what the shifts are. We know the amplitude is 5, so we know it has to go up to 5 and down to -5, right? So that has to be true. Up to 5 and down to -5. All right, the K value is pi over 4. The C value is pi over 2. But remember, this is not the horizontal shift. We have to do something to first find that. So let's first find the period. Use the formula. It's the same as the last problem. The period is 8. So it takes a distance of 8 before it repeats. So from looking at this peak to this peak, we can see from -2 to 6. Oops, let me use my pointer. From -2 to 6, this is a distance of 8 units. So this meets the requirement of a period of 8 before it starts to repeat. So from -2 to 6 is 8 units. That's correct. All right, we have to figure out the horizontal shift. Well, and the amplitude is 5, but we knew that already. All right, horizontal shift. How do we find that? What is that formula? C divided by K, yes. The C value is pi over 2. The K value is pi over 4. Flip and multiply, and then that's how we get 2. And because this is a plus sign, it tells us it's to the left 2 units. If that was a negative sign right here, it would be to the right. But because it's a plus sign here, it tells us it's left. So the original function here would have been here, but because we're shifting left 2, this point goes from here to here. This point that would have been here goes from here to here. So remember, our goal is to graph it. you're given this equation, says, hey, graph this, and you have to plot your midline first and then plot the max or the min. Go for it, Antonio.
Okay, so obviously, if we got to do the math for it, we do this, correct? But if we didn't have to show the math, would we be safe just assuming, since this is a plus sign, we know it's backwards, going to the left, and just ignore this and just make it a 2? Or then that work for all of them?
It wouldn't work for all of them. Just because this 2 here doesn't mean it's going to be a 2 here. Remember, because you're dividing this by the k value, and it so happens when you divide this by this k value, we actually do get 2. But what if this was like pi over 2 or pi over 6 or 2 pi over 3? You would not get 2. So I would recommend graphing this in Desmos or GeoGebra. And you also want to calculate what your period is to verify that your graph is correct. You also want to find out the horizontal shift. I think this is probably the important piece here. But definitely graph it. All right, and that was the test. Pretty easy, right? Except maybe that word problem. But the way they're presenting the answers, it's you just drag and drop from a bank of numbers. Okay, yeah, I expect everyone to get close to perfect on that test. You know, definitely in the 80s and 90s. Nobody should get below an 80% on this test. I really don't think so. I think this, as long as you did your quizzes, you did your homework being the learn and practice module examples and working all of those out. I think everyone should do well on this. I think people who don't do well on this test or past tests is you're falling behind and you're trying to learn the entire unit in probably 1 to maybe 3 days. And that is too much info in a short amount of time. It is not a challenge. I do not challenge any of you to procrastinate to learn this overnight. I would feel bad for you. And you'd be really stressed out, especially if you're a senior and you need this class to graduate and you're barely passing. And no, if you're a senior and you have been basically failing this entire semester and you have not caught up, and I have tried calling you, I've tried emailing you with no response, and then you call or beg me that same week to somehow get you to passing, I'm gonna say I don't know how to help you because I can't. The numbers in the grade book are what they are. And if you're freaking out a week before graduation because you're not passing, why weren't you freaking out today or 2 weeks ago? Why are you freaking out then? So please don't email or call me. I have nothing I can do. It happens every year, whether it's in person or you're online. But anyway, TGA 1, it says graph the function f of x equals cotangent of this quantity. Be sure to clearly label the axis and graph at least one full period of the function. Identify the amplitude, k value, horizontal shift, vertical shift, show necessary work. Yeah, so you can graph this by hand. I would even accept if you happen to graph it in Desmos or GeoGebra and you snipped it and put it in your answer. I would totally take that. I would also, and if you do it that way, I expect everyone to change your x-axis to radians, like I did every example. I will probably mark that graph wrong if you submit it without the x-axis and radians. On your test, you'll have a little box and it'll ask you, what's the amplitude? Put your answer. What's the K value? Put your answer. What's the horizontal shift? Put your answer. What's the vertical shift? Put your answer. Super straightforward question. Number 2, it's the exact same question as number 1, but with a different problem. The same thing. Graph it, label it, radians in the x-axis, please, and then identify all those pieces. Make sure you show the work. And if you just said, hey, I figured out the period from the graph, state that. In your work, say, I found the period by graphing it and seeing the period, and I would take that. If you just give me the period with no explanation, remember, if I don't have an explanation, I don't have work, I can't give you credit. That's math policy, not just my policy. Let's see. K value, you can just tell me how you found the K value. The H shift, I do need to see this work for sure. You just can't tell me, oh, I saw it in the graph. Well, I need to see the work, like, because the horizontal shift isn't just pi over 3. But anyway, I don't want to give anything up. All right, TGA number 3. This is probably the harder problem. This is why we had a bell work on it, and hopefully that you saw that bell work in the previous lesson. I don't know which lesson it was. May have been the last one, the one before that. I don't know. All right, so this one says the range of a secant function is negative infinity to negative 4, then from 8 to infinity. The equation of the 2 consecutive asymptotes of this function are x equals negative pi over 2 and x equals pi over 2. The function is not a reflection over the x-axis. What is the equation of the secant function? What is the equation? And state the parts of the equation. Show/explain how you found the various parts of the equation. So this is just like that bell work problem. Should be easy by now. And the password. All right, so before I show you a password, this is kind of what's going on this week. So we have, today's the review. On tomorrow, the 23rd, is part 1 of the test. You can start it today if you want. I would recommend going through all these problems again, working them out yourself before starting this test. Part 2 would be on Wednesday, the 24th. We are having the review and the test in the same day for your midterm. That'll be Thursday, the 25th. Your midterm is going to be 30 questions, I believe. And then on Friday, we're starting Unit 4, and Unit 4 is long. It is like a month long. It's annoyingly long. If you fall behind in Unit 4, I'm going to say it's nearly impossible to catch up in a few days. So please, everyone get caught up and come to live sessions for Unit 4 or watch the recorded ones. Just stay up to date. And then Raise My Grade is going to be next week, starting on Monday. Remember, you have Monday at noon to Wednesday at noon to submit your request of which test you want to retake. That could be Unit 1 test, Unit 2 test, or your Unit 3 test. Yep, those 3, I believe. Don't miss this deadline. Do not miss the deadline. And that's the password. This is more of a joke because I've said it so many times last unit. No rounding work. Only round your final answer. I have 18 submissions to grade for part 2 of last unit's TGA, and people who rounded their work are going to miss number 2. The link to the slides, yes, we can. Let me post that for you. The link should have the answers, yes. All right, guys, thanks for coming. Good luck on your test.